paper, and when you get back your paper with your mark, upload dalam classroom. Dari situ saya akan key in. So siapa yang tak upload tak adalah markah. Okay? Okay. Now kita recap. Let's recap back what have you been learned. Okay? Throughout the video until minutes berapa yang saya cakap tu? 20 something After that the information you will learn on year 4. Okay, so not in your syllabus. So saya cakap sampai minit ke berapa tu. Tapi at your time masa saya post that link, I didn't say it, right? Tapi dah tengok baguslah extra knowledge, okay? Okay, now we are going to go with power flow of your motor, okay? So power flow, when you have a motor, when you supply the RYB phase, okay? And the power will go through the stator first, right? Dia pergi kat stator dulu, dan baru dia sampai ke rotor. So that's the path of the power flow, okay? So from here, it will energize the stator first, okay? So in terms of the path, so from this one is the input, okay? P in. So you can calculate your P in with cert 3 line voltage, line current, cos theta, or 3 phase voltage, phase current, cos theta. Tapi kenapa? Why? During your lab, you doesn't include this cos theta. So your lab is wrong? No, sure. Why? Apa dia? Girl, apa dia?
Sebab angle apa untuk B dengan I tu kosong.
No, not about that. Tapi boleh diterima, cuma tak tepat. It's not about the angle is zero. There will be always an angle for this one, because current for a motor current IM, there will be always cos theta. Dia mesti ada angle, okay? Cos theta ni, angle ni mesti ada, because you are dealing with inductance, okay? So it's the matter of positive or negative, okay? When the angle is positive, it operate as a motor. But when this angle is negative, it shows that the machine is operate as a generator. Ni semester ni ke? I don't know. Tak tahu you nampak masa synchronous nanti kot. Synchronous machine nanti belajar. Okay? Kita tak take into account this cos theta during your lab, because you already simulating instantaneous waveform. So the waveform is already calculated, the cos theta inside the calculation. Okay? But for this one, it's kind of this one is V, so this one is your I. Okay, so it's not instantaneous, so you need to include the cos theta inside your equation for calculation only. Okay? Alright, after power here is input power, so this is the equation. Okay? When the power go through the winding, okay, we know that the winding has a this one is your stator. Oh, by the way, for power to analyze your power flow, we have two type of circuit. This one and this one. Okay, one with R2 prime over S, and another one is R2 1 minus S over S. Okay, these both is the same, and this both circuit is a per phase equivalent circuit. Okay, and it shows the division part of your motor. For example, okay, this one. This is your what? Stator, pandai. This one is rotor winding. This one is at the shaft. This one is the core. Okay. And this one, to calculate the equation, we need to know what is the, not this one, like here. Center copper losses, the equation is 3I1 square R1. Okay. And we need to know the value of I1. So, how to obtain the I1 is by using this circuit. This is your I1, this is your I2, this is your magnetization current. Same goes to this one. Okay? Okay. We will look into 3 parts synchronously. Okay? The construction, the path, the power flow, and the circuit. Okay. Now from input, okay. So here we have V phase, per phase equivalent circuit. So it is a V phase, and I1 is the I phase lah. Okay, I phase. That's why when we go to the equation, it's 3I1 R1 I1 square R1 multiply with 3, because motor is in 3 phase, so you need to calculate it, multiply by 3 lah. Alright, and then after the power flow reach winding, okay, we know that winding has a component of this R1 and JX1. In the same time, the material of this stator has its own resistive. Okay, it is called core losses. Okay, arrow yang menghadap ke bawah. Okay, the above one is the losses, kehilangan. But this one is the one that you can calculate it. Okay, so now at core you will have 2 losses, which is what? Siapa tahu? Eddy current losses and hysteresis losses. Hysteresis. Okay, eddy current is, ingat tak? Why does the construction is in slotted disc? Ingat tak? The slotted disc kan, dia buat disc, dia susun by one. So that slotted disc actually is trying to reduce this eddy current losses. Okay, and hysteresis is linked with magnetism losses. Okay, alright. Tak sampai lagi. Okay, so now still mingle around winding. Okay, now we reach core losses. Next, when the energy travel from stator to energize rotor winding, okay, it must pass air gap, right? Dia ada air gap tengah-tengah. So in the middle, we can calculate the air gap power. So what is the equation? One, you can look into this line. From here to here, P in, tak pasti lah. This one, P in, minus stator copper losses, minus core losses, and you reach your air gap. So that is your equation. PSCL minus P core minus, tu dah, tu dia. P in, P in minus. So this one is your air gap equation, or air gap power equation. Okay, now after the energy, the energy pass through this air gap and energize your rotor. Now you have losses of rotor, because rotor has its own resistive and impedance, right? This one. Tadi kita dah, you already reach here and here. This one is core losses, your core losses. Okay. This one is your core losses, stator losses, or PSCL. Okay. Now we reach here. So you can see this one, you have R2. So you can calculate the rotor copper losses 3I2 square R2. Okay. There's another term for these two, translated copper losses or rotor copper losses. We call it PCU1 and this PCU2, copper losses. One represent stator, two represent rotor. Okay, stator. Okay. Now, when the energy has reached the rotor, your rotor will start rotate. Okay. So the rotating means that the power is already converted from, this one is electrical, right? IV, electrical. From electrical into mechanical. Okay. So here we can calculate how much power has been converted from electrical to mechanical. Okay. Kalau tengok yang ni dia dah start pakai torque versus speed. Torque multiply with speed versus tu dia punya graph. Induced torque multiply with synchronous speed. Speed yang kat sini, NS. Okay. Kalau dekat sini tak nampak lagi lah. Nanti saya buat penuh dulu. Okay. Now your rotor will start rotating and you can calculate whatever the power have been converted into the mechanical power so that your rotor can rotate. Okay. This one is not losses. Yang ni yang being developed. Okay. Yang bawah ni losses. Okay. At this point, you can also calculate by existing value that you obtained previously, which is, tengok point ni, to this point. So it is what? P A gap minus P RCL. P A gap minus P RCL and you reach your converted power. Okay? Next. Okay. Now it depends whether your motor is operated dalam air ke, submerged underwater, or in the air as aeroplane punya engine, or normal dekat transformer, dekat kita punya ordinary ambience. Okay, so all the ambience will reflect the friction and windage losses. Okay, you bawa kereta, when you drive your car during hot sunny day in Chuping or in Kuala Perlis Changlun punya highway versus during heavily rain, mana lagi laju? Which one will go faster?
Hujan.
Maksudnya yang friction and windage ni rendah. Mana hujan pula? Bila hujan you bawa lagi slow lah sebab resistive friction dia tinggi, dek. Tak sampai pindah lagi. Okay. Itu that's the analogy lah. So when the friction is higher, okay, then you have a more resistance dalam ambient tu, so the friction is higher, losses akan lagi tinggi lah because your motor need to work harder to move. Okay. Alright. And finally, strain losses. Okay. Sekarang it's already operated. So dia operate dekat mana? So what is the ambience? If the ambience is wet, so friction is higher. If the ambient is dry, the friction windage is lower. Okay. And during the whole operation, there's losses that cannot be calculated. Okay. When you calculate, if you analyze, you calculate the PE, you got the PE value, PCU, PC1, PC2 frictions. By right, PE equals to P out plus P balik P out plus P strain, P friction, P RCL, P core, P SCL. Sepatutnya dia akan sama balik dengan P in, right? Okay. But you didn't get it equal. Okay. So there's some losses that cannot be measured and cannot be calculated, which we call strain losses. Usually is 1% of input assumption. Okay. Okay, there's alternative equation for this. A cap RCL done. P out, okay. P out. Okay, previously we can calculate the converted power by using the induced torque versus synchronous speed. This one is here, in the middle between stator and rotor, or in the middle. Okay, but the output here we have another equation with load torque multiply with motor speed or NR. Okay, kalau NR dia kena NR multiply with 2 pi over 60 lah, because the original equation is omega m. Okay, and we can also calculate your P out by looking at this path from here to here. So it's P converted power minus P friction and windage minus P strain. Okay? Okay. If you are involved with designing the motor, you can also calculate your P core. Okay, it's when you know the value of E1 square and GC. GC ni apa? What is G? Dia ada YGB. Conductance, conductivity. Okay, where does this E1? E1 is here. From this point to this point is your E1. If you would like to calculate your core losses. Okay. Then air gap power. There's another term for air gap power. Atas. Which is 3I2 square R2 over S. Sebab air gap dia already reach the rotor. Yang ni. Sebab dia dekat shaft. Okay, sebab tu dia ada dua, rotor winding and shaft. Okay, apa lagi yang tak letak? Air gap dah, RCL dah. RCL, okay. RCL also have another alternative equation which is slip multiply with air gap power. Okay. Converted power pun ada satu lagi. Ada E air gap Y minus S. Or one more, 3I2 square R2 1 minus S over S. This is all converted power equation. Don't worry. Where does this extra equation come from? It's when you involve slip. Okay. If you take a look closer from this point up to this point, it's all electrical terms, eh? Electrical terms. However, from this point onward, it's all the mechanical term. Slip, torque, speed, itu semua mechanical term. Okay. So to integrate between mechanical and electrical, kita akan masukkan slip component dalam equation. If you hardworking enough, you can derive macam mana boleh dapat dia ada derivation dia. Okay. Contoh how come rotor copper losses is S times PAG? Okay, how come does from 3I square R2 dia dapat SPAG? What's name? PAG Letak bawah ni lah. S times PAG. PAG is this one, right? So, S times 3I2 prime 2 over S. Okay. So, you cancel out this one. You akan dapat balik yang ni. It's about expanding and factoring back the equation. Okay. Same goes to others. Cuba try buat yang ni. Replace this one with PAG, PRCL. Masukkan value RCL inside here, you will get this one. Sama je. Dia cuma simplify so that you can have an option whether you want to use the electrical term or mechanical term inside your analysis. Okay. Circuit. Alright. Circuit ni pula, dia ada current, resistive, slip. Okay. Usually, the question will tell you how many slips involved within 2 to 8, right? And 2 to 8%. Aduh. Dekat 25 message tanya. I didn't find 2%, doctor. 2 to 8%. When you measure, itulah dia. Why? 2 per 100. Nampaklah 0.02. Dia nak cari nombor 2 dalam table. Memang tak jumpa lah dia. Okay. Now. Yang mana? Yang mana spesifik? Dari P in sampai P out. In a nutshell, bila you bagi power, kan? Power tu akan ada input kepada output. Okay? So daripada input, from input, dia ada path, dia ada flow dia. Dia akan lalu mana dulu? Dia akan lalu stator ke? Dia akan lalu rotor ke? Where does it go? Where does this power go? Where does this energy go? Okay? So in term of bone, apa ni? Fishbone. Yeah, thank you. In term of fishbone diagram, okay, dia tunjuklah from input nak ke output, tak mana possible losses, tak mana dia akan hilang. Mungkin from input 30 kilowatt, okay, but at output you measure it's only 25 kilowatt. So where does the 5 kilowatt gone? So it's gone. The 5 kilowatt being distributed between all these loss. Okay, and the lower part is losses, kehilangan yang hilang, keluar yang kita tak nampak. However, you can also measure. Maybe you tengah buat operation, does the motor is sepatutnya by right, converted power should be 25, so by right 24 kilowatt. 24, no, should be 30, should be holding 28 kilowatt. And converted power should be holding 28 kilowatt. Okay, but when you measure your output, it's only 25. So what can you do to increase the converted power to 28? It's by looking the slip and the current. Okay, and perasan tak dia ada I1 and I2. Okay, because you are merging. Ingat tak the original circuit? What is the original circuit of this motor? This one. This is the original circuit. One is stator part and one is rotor part. However, the stator part has its own frequency, which is NS. NS here. And you also have your, bukan NS, FSE, right? And at rotor also have its own frequency, FRE. So it's hard to make an analysis. So they are merged. So when it's merged, they are holding one frequency throughout the circuit. Okay, and to make it to make the calculation valid, yang ni dia tak boleh dapat lah nilai sebenar. Dia ada prime kat sini. Prime maksudnya dia dah refer to the stator punya frequency. Dia tak akan pakai nilai yang betul lah. But the analysis is valid because dia nilai dia is almost the same. Okay. Contoh, I2 ni, mana dapat I2? Kita akan pakai I1. We will use I1. Stator current. Okay. Ni saya tunjuk. Okay. Now, fishbone settle. We have all the equation. But how to calculate? We need to find the stator current first. Okay. To find your stator current, they are using this circuit. Okay. We have stator, we have rotor. This one is rotor. Okay. Include the shaft. This one is rotor, but they divide rotor winding and rotor shaft because this one is to calculate equalize the power loss between this one and the fishbone punya diagram. Okay. However, this one is to calculate your stator current. Okay. This one is your what? Impedance of rotor. Okay. So your rotor impedance is Z2 R2 over S plus JX2. Okay, for this exercise or this equation, you must very much expert in your calculator. Okay, ada banyak sini mistake sebab dia salah tekan calculator and salah ambil nilai. Okay, this your Z2 and apa lagi equation ni? You have your Z2. Before that, kita tengok kat awal dulu, kat input. Let's take a look at input. We wanted to find this I, right? So what is I? I equal to, this one I equals to V phase over equivalent total impedance, Z total. Whatever being seen from here. Okay, whatever be seen from here until the end. So that is your total impedance. Okay, so V over Z total. So how to find this Z total? V kita ada. V akan bagi kan phase ke line ke. So how to find this Z total is by simplifying this circuit. Okay, now you have Z2 and then Z stator. We have Z stator here or Z1. Okay, so I transfer here Z1, Z2 and the component of core and magnetization. Okay, so you can see kita nak cari current kat sini. You would like to find current here and the current being divided on I2 and IM. So this one is in parallel, right? So there's another term Z forward. Atau lah forward put. Sebab dia tak F. Ataupun dalam inside the video that you watch the video, they call it Z naught. Okay. So Z naught is Z2 parallel with R plus J XM. However, RC however, the value of RC is much smaller that can be ignored. So we take RC as 0. The one that been left on the equation is just JXM. Okay. So this parallel equation ni jadi macam mana? So 1 over parallel to find your ZF adalah 1 over Z2 plus 1 over JSM, right? So you akan flip the equation. So ZF will be 1 over Z2 plus 1 over JXM. Tu yang dapat. Tu. Okay, and now, where are we? So this all is your ZF. Okay, so it's easier to look, but your circuit now become okay, V phase, I stator, Z1 and ZF. Okay, and from here you can measure your Z total. So that's why your Z total equal to Z1 plus ZF. So this is your ZF. Dalam ZF, inside the ZF is already counted the Z2, your rotor impedance, and the core component, and finally you can calculate the total impedance for the circuit. Okay. This one Z total, and Z2 already mentioned. So next. Okay. And if you put all the equation together inside here, you will have this one. Okay. But this G is being ignored because the value is very small. Okay, so tak payah input lah. Kalau if the value is given during inside the question, you can put. Tapi terus terang cakap kita tak letak lah. Okay. Now you have all the information on calculating the power loss. Okay, I would like to highlight apa yang beza dengan kita punya syllabus. Ini UiTM. Lain sikit lah, makam. Apa yang saya ingat? Okay, this one. The lecturer mentioned about this E. This E is actually what? The phase voltage. Tanda dalam tar. Nanti tanya pula. Okay. This Z node is your ZF. Okay, ZF. And then
maksudnya Z node dengan ZF tu sama?
Sama adik, ya. Okay. Lagi, apa lagi yang lain? Dia ada mention pasal, same goes to this one. Because it's already in phase, so V phase, I phase cos theta ni. V phase sebenarnya. Okay, one more thing. Inside her lecture, dia bagi tahu pasal this mechanical losses lah. Mechanical power. Okay. And this one, apa beza? PM? Okay. This one is also called develop mechanical power, BM. And if you go through her calculation, you see that this one is mu. Mu apa dia panggil? Friction and core. Kan? Ayat di mana? Ni. The total mechanical losses, mechanical and core losses is 1.1. So by right, dia mechanical tu dekat sini. And core losses. Okay. Dia tak tolak step by step macam kita buat. However, dia lump sum dekat hujung last sekali. Here. Dekat output. Baru dia include the mechanical and core losses here. Okay. So it is the same. Kalau you don't bother the division of losses ni, you hanya nak tahu dekat at the end dia berapa banyak losses yang terlibat. Tapi if you really concern of each of losses, okay, oh, I wanted you to design this motor so that it can use in a submerged application. Okay, kita nak buat hydropower kan, nak buat generator untuk hydropower, so dia akan letak dalam air. So we need to consider this individually. So yang tu kena kira satu-satu lah. Tapi I don't care. I just want the output must be 25 kilowatt. Kira tolak je lah sekali harum macam dia buat. So it just the same. Cuma approach nak tengok yang macam mana sebenarnya. Okay. Ini kita dah buat ke?
Tadi.
Tak, you buat ini. Dah ada dah jawapan. Bukan jawapan. Saya tukar nilai je. Okay. Okay, for this example, nak buat example tu ke nak tanda jawapan ni dulu? Tanda okay. Please don't take your own paper. Don't take your own paper sebab I need you to sign. I need you to sign the paper. Lihat dia dulu, kalau bukan, kalau kita you patah ke belakang, kita memang belakang. Dia dah tiba di bawah. Azim mana Azim? Azim mana? Okay, after mark the paper, sign your name and what is your initial? What is your future initial? If you wanted to be a doctor, put doctor in front. You want to be an IR, put your IR in front. Letak. Practice dari sekarang. Want to be a professor, put professor in front. Do you know what is higher than professor? No, your professor Madia is lower than professor. Oh, you don't know?